Hello, everyone, and thanks for coming. It's my pleasure to introduce Arun Pillai, presenting From Spaghetti to Structure, Decoding Complex Code Bases with Graphs and Gen AI. Over to you, Arun.
Hello, everyone. There are three certainties in life: death, taxes, and zero chances of a developer willing to document. Why do I say that? 96% of our customers have told us how lack of documentation has come to become a major blocker in their modernization efforts. 41% of respondents to this particular survey had something similar to share when it came to productivity and the barrier to productivity because of the same reason, lack of documentation. Now, this is all good if you hedged your funds in technical debt, because as it stands, a good portion of our IT budget globally will be consumed in maintaining these technical debts. If not taken care, then these debts will only compound. So we want to do the right thing. We want to take these legacy applications and modernize them. We want to build up a team who can go and fix the solution. We say, take a chance. Are the original developers, are the original experts on these legacy applications around? Less chances of that. They probably have moved on, retired, maybe even in some cases. So what's your next best bet? Application documentation. Now, what are the odds of that being around? So with little, or in some cases, no documentation, you do not have the confidence to embark on this app modernization journey. What do? You let the opportunity slide. You let technical debt compound. Now, this is a problem that if you don't fix, then the cycle repeats. 2 years ago, we here at version 1 set out to figure, could we do something about this problem, this boulder of a problem sitting on the tracks of app modernization, sometimes holding you back, sometimes not letting you go at all? How can we de-risk and accelerate modernization? I am Arun Pillai. Let me talk you through how, using generative AI and powered by graph databases, we may have a solution to this problem. What's the challenge here? We have legacy code, legacy application, lack of documentation. Why is that a problem? Because without documentation, you have to get into a time-consuming exercise of understanding, comprehending these applications. The expertise is missing, documentation is missing. That's the challenge we have. Comes to the scene, generative AI, large language models. We all know, we've all tried our bits now, experimenting with, okay, here's my code snippet. We've got code assistants in IDE. We know what they can do. So that's where we started. We took code snippets, sent it to the LLM, asked a few questions. We liked what we got back. It even came back with improvement tips. Fix this. This is a little bit of a vulnerability issue I can see here. This is not good practice. I can see code smell. So that's all those things, all sorts of things that we want to capture in a document, right, for an application. But it's not just code snippets. We want to document at the application level. We want to capture the application behavior, the business logic. So we knew we had to extend the LLM capabilities. We had to take it from not just code snippet, not just file, but the entire application. And that's where we met our first challenge in our early days. Context window constraints. We cannot just chuck the entire repository at LLM, at that stage at least, and say, okay, bring me the documentation. We understood in the very early days that we had to break the application down into smaller chunks. Now, if you take a Java application or any object-oriented language, C#, you probably want to go down to the levels of methods, the classes therein, the interfaces therein. If you're talking about PL SQL, then you're talking procedures, functions, cursors, triggers, packages, maybe even. So what did we do? We built a parser to using regular expressions to extract these code elements, these symbols that you find in source codes. We took these along with prompts that we had figured from our early experimentation that work to the generative AI, to LLMs. We got the response back. We asked specifically for introduction sections, purpose. What's the conclusion? Are there any gotchas? So we had asked these specific questions. We worked on our prompt engineering skills, and we built out a parsing mechanism and parsing and summarization mechanism. The early results that we saw got us excited. We got so excited that we even named the tool. We called it Decipher with love. But it's all good to just do all these exercises internally. We wanted to check this out with real applications. So we went to a customer. They seemed interested in the idea, but weren't very confident. So we said, let's have a go at it. We did. Initial round success. Then they gave us the real thing, a larger repository. And that's where we failed miserably. An application that talked about inventory management ended up mentioning carbon footprint analysis because there was 1 or 2 lines about it. Recency bias, hallucination, all the terms that you all should be familiar by now, probably was the reason behind the divergence there. So what we realized is it's not just context window that's an issue here, but with larger code base, memory. How does LLM retain memory? How do we give that context? But what is the context? We gave it the methods, we gave it the files, we gave it the folder, go summarize, folder level, give us the application document. At a moment, in our senses, we realized an application is not just the files. It's not just the methods. It is the interaction between these elements. You have method A in class A, which interacts with method B in class B. You take a RESTful API, you have the controllers, API controllers. From there, you go into the service layer. Then you go to the repository layer. Then you might be going to the data access layer, out to the database, or maybe a third-party system. So there is all this interaction which can never be captured if you are only focusing on the structural hierarchy of your source code, which is the mistake that we did in the first approach that we had. So with this realization that we are missing out on interaction context, we are missing out on the context itself, not just the context window, we manage that well, but the actual context of the data that you're supplying to an LLM was being missed in our case. We went back to the drawing room, sat down and say, okay, what can we do about this? We want to capture the code interactions. We want to traverse the call stack as I mentioned earlier. Now, this could be, I give an example of a RESTful API, but in batch processes, that looks different. If it's an MVC application, that might look different. If it's just a UI SPA, then that would look different. So regardless of what the application is, it is actually a set of processes, a set of call stacks, set of interactions. How can you extract that? The first thing that came to mind was, we have to traverse the abstract syntax tree. So we shifted from extracting the code elements using regular expression to using abstract syntax tree to extract the code elements and their interactions. But there's only so far that we can go down this route as well. Okay, when I pick up a Java application, I've got the methods identified in a particular class. I can also trace, are there any method calls? But then, which method call, which class does this method belong to? The calling method, the caller method. We had to capture this relationship. We had to look at a different model to capture this relationship. Yes, we got the code elements. Yes, we got the relationship. We put them in a symbol table. We will resolve the symbol names, all good. But unless we capture this in a data model, there was no way we were going to utilize this in a way. We wanted a model which would capture the code relationships, one that prioritizes interactions over hierarchy of the folder structure. And that was our moment of breakthrough. We took the code elements and the relationships into graph database. We used Neo4j for that purpose. Once all the code elements and their interactions, their relations were plotted on this graph database. We wrote Cypher queries to find out entry points. As I said earlier, in batch processes, the entry point would be slightly different from the entry point that you would find otherwise in an API-based source code. It would be different in a UI application. But regardless, once it is into the graph, you find the entry point, you follow the relationships, you follow the edges, you get call stacks or processes, in other means, because that's what applications are. They are a bunch of processes, each doing different things, sometimes related things, and that's where you can catch the entanglement. If you have a process that is dependent on other related processes, you can extract those processes, you can extract the community of graph from this big graph that you would end up if you were to scan through the entire source code. Why stop at processes? Group them into domains. Okay, this particular set of processes is talking about finance in an organization, or this one is talking about teachers in a school-based application. All of this can only be possible if you capture the relationship between these. And graph database is what enabled us model and go towards further in this direction. Let me show you how our beloved tool Decipher looks these days. This is a particular Java application which has been, as I said, parsed and plotted onto the graph database. We have surfaced this into a web application. All across this graph is all the nodes, all the relevant elements, the methods, the classes, the interfaces, and their interactions that we have captured. And then we took each node to the LLM with the relevant context, with the related elements, graph rag in action. And I have selected a particular node here. You can see I've got documentation on that node. What's the purpose? What are the input parameters? What does this return? Give me an idea of the control flow here involved here. With this documentation at each node level, what then I can do is build up other elements, other levels of documentation. And this is an example of a Java application. Let me zoom out a bit and show you the vastness of this particular graph here. And it's not just the entanglement, but you can also see in the peripheral there are a few elements that are not linked to the application. That's another useful insight. But all this only possible if you take this further out and inquire more on them. Let me show you how, by identifying the community graphs that I mentioned earlier, we can look at processes. So this is a subset, a community from the big graph that we saw there earlier. We connect, we follow the call stack, we follow the edges, we follow the relationships, and identify processes. Once we have identified the processes, we have the context, we have the related elements, then we go to the LLM with the appropriate context. Now, it's not just the code element. The whole idea is, yes, get the code elements into graph. You've got related nodes, but the key is in enriching these code elements, enriching your data model. And the flexibility that you get with graph database in the enrichment process is what we are targeting on. For example, once we plotted all these on graph, all the code elements on graph, the next thing we built is a node scanner. For every code element, for every node that you have, we look in the source code and identify, are there specific business rules that could be extracted? Are there integration points to external applications, external APIs maybe, or to databases? Are there particular actors involved, system roles, admin roles, particular type of user? We captured all this through node scanner functionality that we introduced into this workflow, and then enrich the graph database, enrich other nodes that are already present there, and then use that information to document. So we did that at the process level. And what this also has allowed us is to draw up sequence diagram. Have a look at this. So identifying the users. This was again part of node scanner, but plotting it onto the graph related to the process. And this allows you to comprehensively document one particular flow. Now, if as a developer, I'm coming in tomorrow to develop from legacy application, I've been given this sequence diagram. It makes my job so much easier than having to sit down and take myself through the actual source code. All possible because we made use of graph to capture the essence, the knowledge that we want then to comprehend and then utilize into the modernization efforts. Let me get out of sequence diagram. I mentioned why stop at processes. We did it. We categorized the processes, looking at their documentation. We found out semantically similar processes. We made clusters using K-means algorithm, and we said, okay, if these processes are related, if they are talking about similar things, they must be, we could group them as domains. And then you can document at domain level. So in this particular example, we've got 8-9 domains that we could identify automatically on the basis of the data, the knowledge that graph allowed us to take to large language models. So for each domain, we have documentation available. Once we have documentation at domain level, which was enriched with the collection of processes, we can go a level up at application level. This gives you the design document that we were hoping to bring here. And it looks like I have a little bit of a glitch here, but the point I'm trying to make is once you rolled up the domains, you get to see the design document at the design document level. There it is. At the design document level, we have system architecture diagram. And again, this is possible because we used the graph to identify the domain nodes that we have now in the graph database, and the linked actors, the linked external dependencies. Using that, we document at a high level as well. That's where Decipher has come up to. Now, what's there more for Decipher? It's all good to have the graph ready, but then what next? What lies ahead for Decipher? Documentation, naturally, we can take away and go build application on the basis of that, but it would be nice if you could take this one step forward, one step further. User stories. So there's no reason why you cannot take the raw documentation or the high-level design that I just shown you there and take it forward and convert it into user stories with the help of generative AI, of course. Currently, Decipher only does a static analysis of the source code, scans your source code, and then generates the documentation, graph-powered, and GenAI, of course. But imagine if you could execute the application and capture the runtime interaction and the performance metric and enrich that data into your graph database. You have a whole new set of knowledge that you can then take to the generative AI or large language models. Same thing with code health integrations. We are thinking about SonarQube integration with our tool. SonarQube will give us the health or the vulnerability reports, the security scan report, and then we can use this enriched, integrated into the graph database, then go to the large language model. So in essence, yes, generative AI is giving us the natural language response, but it's the graph which sets the foundation, the essential truth, the source of knowledge that will bring out the complexity and make it clear from what the legacy code bases bring to you. So it's not just yeah, I can throw the entire repository at generative AI and I'll get it. Someday probably, yes, we'll all go the AI models that are coming out, they'll get more powerful and stronger. But at the moment, it's the context of your source code that is sitting in your repository that needs to be built in a way which can be broken down, the relationships understood, the processes understood, the logic understood, the domains entanglement understood. Once with this understanding, the ability to extract these complex relationships and take it to large language model. Decipher's role is just to bring these two together. The tool that we have built is only trying to bring these two together to deliver clarity from complex code bases. Thank you so very much for listening in. Appreciate your time. Any questions, please use the forum. Otherwise, I'm available on LinkedIn. Please reach out. Love to talk about what Graph is bringing on, GenAI is bringing on. Would not shy away from any chat. Thank you very much.